Swayam Prabha. Digital India. Educated India.
Good morning and welcome to this next lecture on vibrations of plates and shells. We were looking at the 5 equations of motion term by term in the context of a spherical shell and trying to see the physical meaning of each of these terms. So we started over here. This is the alpha 1 equation as given in the book with the negative sign. We are going to change the sign and look at them, and we had looked at this term, we had looked at this term, and this term the del A1 del alpha 2 is 0. So we did this term also towards the end. What is left for alpha 1 is this term over here. So let me start. So we have the axis, the axis of rotation, and this is my element. This is my phi over here. This is d phi exaggerated. And the particular term we are looking at is q phi 3 sin phi. Okay. So now how does it work out? So q phi 3 on the phi face in the 3 direction works like this. It has this direction on the negative side and this way on the positive side. Q phi 3, Q phi 3 plus del Q phi 3 by del phi d phi. Okay. The angles are not actually correct, okay. They will point towards the center. For example, this will actually point towards the, go through the center. Similarly this one, but in these diagrams it's very hard to keep everything in order, okay. So now we are looking at this contribution. So now here I can draw. I have d phi by 2, d phi by 2, and this is the negative side, let's say. So the resultant is q phi 3. This is the positive side, q phi 3 plus del q phi 3 by del phi d phi. And my positive axis is this way. So I have contributions in the 2 directions, components in the 2 directions, and this is the component I want from both sides. Okay. So if I make this a force, first of all, q phi 3 into r sin phi d theta, that is a force. Then I want its component. If this is d phi by 2, that is d phi by 2. I want this component, so it's sine d phi by 2, which is d phi by 2 again, because it's a small angle. So into d phi by 2 plus q phi 3 plus del q phi 3 by del phi d phi into r. This length is bigger, so we have to account for that. R sine phi plus d phi d theta into d phi by 2. Okay, so let's look at this. We get q phi 3 r sine phi d theta d phi by 2 plus, we will expand all of these. So q phi 3 plus del q phi 3 by del phi d phi into r d phi by 2 sine phi cos d phi, which is small, plus cos phi sine d phi, which is d phi into d theta. Now here we have d theta and d phi. So we will take from here also terms with two differential elements. So already I have d phi and d theta. Okay. So I can't take this anymore because that's another differential. I can't take this, which is another differential. So I will take this multiplied by this and the differentials. So that is the same actually. So that gives me it gives me q phi 3 r sine phi d theta d phi. Okay. So which is what we have. I put an r d phi d theta here at the same. Okay. So that more or less completes the forces in the alpha 1 direction or phi direction. The remaining is the inertia term. Inertia term and the external force. Okay. Now, next we look at the theta equation of motion. Theta equation of motion. And after all the corrections and sign changes I will give you, what we have is del alpha 1 n1 2 a2 plus del alpha 2 n2 2 a1 plus n21 del a2 del alpha 1 minus n11 del a1 del alpha 2 plus a1 a2 q2 3 by r2 plus the external force is equal to the inertia. Okay. So we'll note this as 1, 2, 3, 4 and 5. Okay, so term 1. So let's look at term 1. Term 1 in the spherical coordinates looks like del by del phi, n12 is n phi theta, a2 is r sin phi. Okay, let me take this to the next page. So term 1 looks like del phi of n phi theta r sin phi, and so we draw the picture now. This is my axis of rotation, my element, okay, this is the phi angle, this is d phi, and we are now adding in the theta direction, which is like this theta direction. So first of all, n phi theta on the phi face in the theta direction is, let me change color, n phi theta, and then augmented n phi theta plus del phi n phi theta d phi. Okay, and they are going to contribute in the theta direction. Okay, so let's see now. These are force resultants, so I have minus n phi theta into r sin phi d theta plus n phi theta plus del phi n phi theta d phi, and this length is also incremented, so I need r sin phi plus d phi d theta is equal to minus n phi theta r sin phi d theta plus n phi theta plus del phi n phi theta d phi r d theta into this expansion, which is sin phi cos d phi plus cos phi sin d phi, which is d phi. Okay. Now if we open it out, I have minus n phi theta r sin phi d theta plus n phi theta sin phi r d theta. Next I have plus del phi n of phi theta d theta sin phi r d theta. Okay, this and this, then last is this with this, okay, plus n phi theta r d theta cos phi d phi. Okay, I am deliberately ignoring these two, the product of these two. I have three small differentials here, so it is much smaller than the others where they have only two differentials. So now if we cancel, this cancels with this, I am left with two terms. Those are del by del phi n phi theta sin phi r d theta d phi. This should be phi plus n phi theta cos phi r d theta d phi. So we can write this as del by del phi n phi theta r sin phi into d theta d phi, okay, which is what we have over here. Next, the next term is term 2. Term 2 is del theta n theta theta, A1 is R. Okay. So if we now take the axis of rotation, phi d phi n theta theta is like this and like this. This is n theta theta and this is n theta theta plus del n theta theta by del theta d theta. So if we make, these are force resultants, so if I make a full force out of them, I have minus n theta theta into r d phi, okay, this length is r d phi, r d phi plus n theta theta plus del theta n theta theta d theta into r d phi. Okay, this is r sin phi, I have not pointed it out earlier. Okay, so now this cancels with this term, and so I am left with del theta n theta theta into r d phi d theta, which is what we have here. Okay. Now the third term. The third term. Term 3 looks like n theta phi del by del phi of r sin phi. Okay, so let me draw that. We have the axis of rotation, this is phi, this is d phi. Now n theta phi is on the theta face in the phi direction. So I have this here and this here. Okay, and this of course is r sin phi d theta, and this length is incremented r sin phi plus d phi d theta. Now we are looking for the contribution of this force and this force in the theta direction. So how do we look at it? We look at it vertically from the top. Look at this from the top. If you look at it from the top, it looks like this. Okay, where this length is r sin phi d theta, and this length of course is r sin phi plus d phi d theta, and the force on the left is on the negative direction, which is n theta phi. Here it's in the positive direction, n theta phi plus del del theta n theta phi d theta. Okay, and that's still a resultant. Okay, now this each of these resultants has components vertical and horizontal, and this is the theta direction. So both resultants will add in that direction, but we have to figure this out, which requires figuring out this angle. Okay, or figuring out this angle. What is that angle? In order to figure that angle out, I need to figure this distance out. Okay, so now I have the total distance is r sin phi plus d phi d theta. That is the total length here, which if I open out is r sin phi cos d phi plus cos phi sin d phi is d phi d theta, and this length is r sin phi d theta. Okay, so if I take the difference minus r sin phi d theta, then I get r cos phi d phi d theta. Okay, so that is this length plus that length, so I divide by 2. That is this length. If I divide by this length, which is r d phi, that is now equal to tan alpha. Okay, tan of this small angle, and for small value, so let us see what that is. That is r d phi, so it's cos phi d theta by 2. It is a small number, and therefore we will approximately take it as sin alpha and alpha. Okay. So now if that angle happens to be this alpha and this is alpha, then I need the component here which is sin alpha and therefore alpha itself. So the components of both resultants in that direction are n theta phi into r d phi, which makes them a full force, into alpha, sin alpha, which is alpha, cos phi d theta by 2, and for the other force we have n theta phi plus del theta n theta phi d theta, make it a full force using r d phi, and then sin alpha or alpha, which is cos phi d theta by 2. Now here I have one differential and one differential, in here I have one differential and one differential, but if I include this, there is one more differential, so this term I am going to neglect, and these two are equal, so I get n theta phi r cos phi d theta d phi, which is this term here. Okay, but let us remember, we have to use this again, that this small angle that I have, the tan alpha is equal to cos phi d theta by 2. Okay, we will need it. Okay, that is term 3. Then we have term 4. Term 4. Term 4 is minus n11 del A1, which is del R by del alpha 2, which is del theta. Okay, so this is phi phi. This is 0 because del R del theta is 0. Okay, then term 4. I mean term 5. Term 5 is A1 A2, therefore R square sin phi R square sin phi Q23, which is Q theta 3 by R2, which is R. So that is equal to R sin phi Q theta 3. Okay, Q theta 3 R sin phi. Let's see. Q theta 3 R sin phi. Now, this is my axis of revolution. Okay, and here again is my element. This is my element. This is my phi direction. This is d phi. Okay. Now Q theta 3, okay, is on the theta face in the 3 direction. It is in the negative direction and it's here in the positive direction. Okay, so this is q theta 3 and that is q theta 3 plus del q theta 3 by del theta d theta. Okay. Now they ideally should be, let me draw it that way, they should be pointing right towards the center. Okay, they should be pointing towards the center like this. Both of them should go through the center. Okay, because it's a spherical surface. Now, so what is this distance? What is this distance? Okay, that distance based on A2, okay, is r sine phi plus d phi by 2 d theta. Okay, I am considering this point to be at d phi by 2. So this length is, okay, r sine phi plus d phi by 2 into d theta. That is this dimension. Okay. Now if we look at it in a different angle, if I draw this looking at it this way, so it looked curved, this force will be pointing downwards towards the radius of curvature or towards the center, and this one will be pointing upwards. Okay, so this force is q theta 3 and this is q theta 3 plus del q theta 3 by del theta d theta. Other they are resultants. So I need to multiply by this length, which is r d phi in both cases, r d phi, r d phi, and this length is this length. Okay, and as they are pointing towards the center, this length is r for the sphere. Now if I open this one out, I have r sine phi cos of d phi by 2 plus cos phi sine d phi by 2, which is d phi by 2 into d theta, and so I will drop this in comparison to this. So it's more or less r sine phi d theta. So that length is approximately r sine phi d theta. So then in this plane of this line and the normal towards the center, so in this plane this angle is r sine phi d theta, the arc length over radius, and therefore it is sine phi d theta and half of that. So this angle is sine phi d theta by 2. Now I would like the component of this force in the theta direction, that means in this direction. So if I break it up, if I break this also up, so this is what I want and this is what I want, and so both are adding in the same direction. And if this is alpha, this is alpha, this is 90 minus alpha, so I am looking at sine of alpha. Okay, and being a small angle, it is this itself. So the forces in the theta direction, this is my theta direction, are q theta 3 r d phi into sine alpha or alpha, which is sine phi by 2 d theta into 2, because this is going to be a small term. Okay, so that gives me q theta 3 into r sine phi d phi d theta, which is what we have over here. Okay, so that finishes the second equation. The remaining terms are the external force and inertia. So what is left is the third equation of motion, which we will do in the next class. Thank you.